We will demonstrate this Y110. Now we are looking at the Y110 oxygen filtration tester. Perform an unpacking inventory. We have a hex wrench and a cross screwdriver. There are also two 12mm open wrenches. This is the communication cable. The communication cable is used to connect the instrument to the computer. And then there's the syringe. There is also a sealing support. It is used to paste samples during experiments. This is the 220-volt power cord for the instrument. This is the sampler and sampler. And here are two stainless steel tubes. One is oxygen. The other one is for nitrogen. And there's a folder in there. There are spare connectors for the trachea inside. And the standard film of Guangzhou marking. And the manual for the instrument. Certificate of Conformity Packing List. Product Maintenance Warranty Record Card. And Factory Inspection Report. There is another USB stick we match. There is software for using the instrument in the USB stick. Here we go. We demonstrate the installation of the buckle on this steel pipe. We take this accessory out of this accessory bag. An 1/8 endpoint card holder. Then are an 1/8 endpoint card sleeve. It's made up of 3 components. First of all, this is the nut. We are the nut connecting the instrument. And there are 2 locking sleeves. These 2 locking sleeves are stuck on our steel pipe. So what about the order of this installation? Is to put this nut in first. Then we put this little card holder. For this card sleeve, it has a slot. Our little circle faces up. This is what it looks like. Put this tapered condom on again. Then tighten. After screwing, we need to use our matching 12mm open wrench. Just tighten it up. After tightening like this, please pull out this card tape by hand. See if you can pull it out. Make sure you can't pull it out. Then we release it. After loosening our locking sleeve, it will be completely stuck in the steel pipe. This way our nuts won't come out. Remove the instrument power cord. The power cord has 2 ends. This end is connected to the port on the instrument. Then the other end, connected to a 220-volt power outlet. Remove the communication cable of the instrument. Here are the communication interface and the debugging interface respectively. The communication line of the instrument. Just plug it into the communication interface. You can plug it in. And here are the screws to tighten it. After connecting, take out the steel pipe in the accessory box. Connected to this nitrogen connector. Be sure to tighten it when connecting this interface. Don't throw away the blind plug you took off. Put it together with the connector inside the accessory. When the instrument needs to be moved, you need to connect this plug back first. Block this mouth. Then move again. The instrument needs to be connected to this nitrogen port first. Do impact line experiment. When it comes to experimenting, then connect this oxygen interface, because there is a security issue involved. If we connect nitrogen to this oxygen interface, it's got a deoxidizer inside it, will generate high temperature. In that case, the whole instrument will burn. So we have to pay attention to safety here. Before hitting the line, you can leave this oxygen interface alone. Just connect it when we do the experiment. Nitrogen steel pipe for the instrument. The other end is attached to this pressure gauge. You need to use one of our 12 mm opening wrenches. Reinforcement. Our joint must be tightened. Otherwise, it is easy to leak air. After connecting our nitrogen steel pipe, it has a pressure regulator here. It comes with a valve switch. What about the other one? It is a total pressure valve for our nitrogen cylinder. So when we turn on this gas, we need to open the master pressure valve for this cylinder first. Before opening, we need to pay attention to our pressure regulating valve. This partial pressure valve above, is it in a closed state? After being in a closed state, we can open the master pressure valve for this cylinder. Unscrew counterclockwise. No need to unscrew it completely. It can be unscrewed about half the distance. And here are two tables. We are a total pressure gauge and a partial pressure gauge respectively. The one on the right is our total pressure gauge. This shows the pressure of one cylinder. And here's the pressure gauge. That's what we output to the instrument. A pressure gauge. Then after opening the cylinder main valve, we adjust the partial pressure valve. Clockwise is open. Counterclockwise is off. What about when we turn on this nitrogen? Don't twist it too fast at once. We're going to screw slowly. Turn this pressure to 200 billion. Look at the voltage gauge and adjust it to 200 billion Pa. And then, next, we need to carry out to the output line of this cylinder. Perform a test of sealing. So our current partial pressure valve, after 200 billion, stabilize for about 10 minutes. Then close the partial pressure valve. Let it sit for half an hour to more than 2 hours. And look at the hands on the pressure divider. Is there a significant decrease? If there is a decline, then our interface is not connected tightly. You need to take it apart and tighten it again. Then another way. We can soak water with soap. Check if this interface is missing. We take soap foam. Smear it on this interface. Observe if our bubble gets bigger or reduce. If there is, it is an air leak. Next, we will demonstrate the loading of the instrument Y110. First, open the protective cover of the instrument. Then open the gun of the instrument cover. The hood is an 8 mm hex wrench. Loosen the screws on both sides first. Then unscrew it all. Put the cap aside for now. Take this foil off the device. Don't throw it away after taking it off, because the baseline needs to be charged first during installation. Just use our aluminum foil to fill the baseline. Then this seal on it. Just use a clean tissue. Just regular paper towels. Wipe it clean. Then remove the aluminum foil. And then we're just going to take regular clean tissues. Just wipe the seal on it first. Be careful not to wipe it with water. Just wipe it directly with a dry ordinary tissue. Reapply bee juice after wiping. Just take an appropriate amount of bee juice, not so much. Slowly apply evenly like this. Note that this sealing grease is not the more you apply it. The more airtight it is, the better. But to apply evenly, just have a thin layer. After applying, apply aluminum foil. When applying aluminum foil, try to center this aluminum foil. After applying the aluminum foil, you need to put this lid back on. Pay attention to the upper cover of the instrument. There are 3 sealing rings inside. This sealing ring cannot be dropped. If it falls, there is a spare sealing ring in the spare part of the instrument. Then when tightening, it needs to be tightened in balance. It cannot be tightened on one side. Tighten it again, the other side. Just tighten the screws. Needless to say, it takes a lot of effort to twist until you can't add force with the wrench like this. Don't screw it tightly. Then close this protective cover again. Turn it on after the samples are all loaded. Just press this switch button. The switch button has a blue indicator light. If the blue light is on, it means that the instrument has been powered on. Then take out the USB stick from the accessory box. Plug it into the computer. Open our USB stick. There will be instruments, operating software. Double-click to open. Then copy these 3 files. Put it on our D or E drive. Note that it cannot be installed on the C drive. Then you can create a folder. Copy all the software to the folder. There are 2 in here, our compressed package and a folder. Then this PL 2303 aluminum serial port is a driver of our communication line. Another one is the compressed package of the instrument software. Then we have already decompressed it here. Then open the folder. Pull down this folder to the second to last. TGL application. Right mouse button to send it to the desktop. Then we open the software. The first login is a default account and password. The password is the same as the account name admin. Then click to log in. Now the data like this is all 0. Didn't beat. Then this proves that the instrument is not powered on, or the communication line is not installed properly. Here, you need to select the CON port of the communication line. Then click Save. So where is this serial port checked? Minimize the software. Click the computer with the right mouse button. Then click Manage. Click Facility Management again. Finally, click on the port. Here is one of our green links, a COM port of the communication cable. Then you can see the COM number here. For example, this is COM 6 now. Then we need the serial port of the software here. Select COM 6, then click Save. Click Test again. Now we are on the phone. It's all happening in real time. Then you need to go to the debugging interface. Click PID again in the debugging interface. At this time, we need to observe the PID value. It's 0 now. You need to click to refresh. Let it put the PID value in the instrument. Upload it to the software. Take to More, then save it. Take out our factory inspection report. There is a factory parameter setting in the inspection report. This calibration value we need to check. Need to compare. Is the software display consistent with the factory report value? The transmittance is 0. Corresponds to a voltage value of 0.48. Compare one by one. Check if our values are correct. Then go to the equipment debugging. It depends on whether the set value of the filter is consistent and whether the sensor correction values are consistent. Then go to the parameter correction interface. Here are the temperature parameters to be compared. Humidity parameters and flow parameters. We can check them one by one. After checking and confirming that it is correct, click on the home page. Go to the test interface. Here we click to run directly. The instrument installed for the first time requires an impact line. Sample type here. It has the functions of film and packaging respectively. Then this instrument can only choose the thin film mode. For the type of experiment, we need to choose the impact line. There's a thickness here. Thickness means the thickness of the sample. This is according to the thickness of the measured sample. And you feed in the actual thickness. Thickness is expressed in microns. Then the area is 50.24. It represents an area of the gun body. This does not need to be modified. Then choose and click directly to start the test. There are 3 status displays down here. The first is the test state. Displays the current operating status of the instrument. The test time is a cumulative amount of time. Process time is a time in the current process. So where is the order of this process? Click on the home page. Then click the debug interface. Then click process settings. Then there are impact lines here. Calibration and testing. We are now the impact line. So this is the process he went through. First of all, it's temperature controlled. Temperature control to the set temperature, then bypass. Rinse after bypass. After rinsing, the impact line of a cavity is carried out. We return to the home page. Then click Account Security. There is User Management here, Rights Management and Account Security. User Management here we click Add. You can add an account of our user. The account username can be in English or Chinese. Then the user password. Be careful with uppercase and lowercase letters, numbers and special symbols. Note that the second level password and the user password cannot be the same. Group type double click. There's a down arrow. Click to select System Admin. Instrument Manager, Auditor Operator according to actual selection. For example, the operator. We choose the operator. Then the user status is also double click. There are 3 states. This is allowed to stop. We click Allow. This account is allowed to be used. Click Ban. Then this account is prohibited and can no longer be used. Same with stopping. Effective days. It is usually set for 180 days here. Then after 180 days, it needs to be modified by the system admin again. Remember to save it after adding it. Then this account has been saved. And then access control. Here are the permissions for each level. If it is in a green state, then this user can use the corresponding permissions. If changed to gray, then this user cannot use this function. Click Save after changing. And then there's Account Security. You can set the number of days this account is valid. The number of errors is to enter the wrong password more than 3 times. Then it will freeze for 15 minutes. These can be changed. Just double click to modify it. After changing, you also need to click Save. Then go back to the home page. Go to the debugging interface. Point equipment debugging. Here are valve debugging and temperature control settings. This is mainly to check whether the instrument is running normally. Return to home page. Go to the test interface. Note that the following is currently in bypass state. In the bypass state, check whether its outlet is normal. Take out the 4mm trachea from the accessory box. Insert it into a gun, the lower gun and the upper gun respectively. Then take a container. The container should be filled with water. So let's start with the state of the instrument in the bypass process. Put the pipe in the water. It will have bubbles appear. I have to vent. You can't breathe when you shoot. Then shoot. You can't get get angry when you shoot. We are now in the impact line experiment. After bypassing just to the flushing process. When flushing mode, a gun doesn't blow. Then the gun will vent. You can't breathe when you shoot. Then to the impact line of a gun. Same here, a gun is airtight here. Then you have to take out your breath when you shoot. You can't breathe when you shoot. So, what if we were in test mode? The upper and lower chambers of the instrument need to vent air. I'll show you that later. Then after the impact line is over, a prompt box will pop up. You need to click Save. Then the latest mechanical voltage value. It will be automatically saved to the calibration of the instrument. Click Save. After charging the machine, you need to connect the oxygen interface. Likewise, take out another stainless steel pipe. Put it on. When connecting, this nut must be tightened. Just connect it like this. Then the same is true for leak detection. You can refer to the previous method. After connecting the steel pipe for oxygen, the first thing to do is to adjust the pressure of this oxygen. The table on the right is the total pressure gauge for the cylinder. This is the partial pressure gauge on the left. It's the voltage gauge that goes out to the instrument. Then this total pressure gauge clockwise, it is off. Counterclockwise is open, like when adjusting this pressure. First of all, you need to release this partial pressure valve clockwise. Release and then open this total pressure valve. After opening the total pressure valve, adjust the partial pressure divider valve is adjusted clockwise. Transfer to 100 billion. And we're going to demonstrate this sampling. So first of all, we have the sampler position. There is a safety buckle. When the safety buckle is locked, then this sampler can't be pressed down. So when we want to use it, you need to pull this safety buckle out. Then rotate 90 degrees. To this state, it's open. This is when we sample. The sampler can only be depressed. Remember to lock this safety buckle after use. Then we take out a sample that we need to test. Put it on the sample board. Then we put our sampler on top of the sample. Release this safety buckle. When we sample, be sure to hold the base of this sampler with one hand. The other hand presses the rotary cutter. When we cut, don't press too hard. As long as the blade can touch the sample. Then press and hold to rotate and rotate once. After one rotation, let's lock this safety buckle first. After locking, then take off our cut sample. This is a sample we cut. After we fill the baseline, standard module verification is first required. Open this protective cover. Open the lid of the instrument again. Put the lid aside. Then remove the aluminum foil. Then use regular clean paper towels. Wipe up the original beet juice. Pay attention to the cavity of the instrument. It must not be wiped with water. When you need to clean, you can dip a little high concentration alcohol to wipe. After wiping it clean, we need to repaint with beet juice. Get the right amount of beet juice. Apply evenly. After applying evenly from the accessory box, find out the box of Guangzhou marking standard film. Standard film comes with a certificate. Then take out the 125 micron standard membrane. Apply the standard film to the top of the lower cavity. Smooth the edges. After the standard film is pasted, we need to put the upper cover on. It's also important to remember that has the sealing ring of the instrument fallen out? Then tighten the gun cover. Pay attention to the balance of forces on both sides. Compress. Then close the protective cover. Instrument impact line done. After applying the standard film, then click Run Need. Select the test mode in the experiment type. And at that point we are going to have a template. First of all, the thickness here is 125. If not, enter 125. Note that the area cannot be changed here. Must be 50.24. Then the testing unit fills in according to the actual situation. Then test the sample. For example, our current one is 125 micron standard membrane. Then check the standard. You can choose the national standard or other standards here. If there is no one here, then we can click here to modify it separately. Then the sample source, sample batch number, sample specification. Fill in this information according to the actual situation. Click to start testing. Then it can be observed at this time. The status display of the instrument. Then when the line is bypassed, let's check the outlet. So again, we're going to take a container, fill it with water. Put the tube in. What about the bypass status of the instrument test mode? A gun can breathe. Then you can't breathe when you shoot. The gun is also equally breathless. After that, the instrument enters the flushing process. It won't blow a gun at this time. When you shoot it, it's going to vent. You can't breathe when you shoot. What about after the rinsing process is over? Instrument test mode. A gun is not out of breath. The next shot is to vent. You have to get angry when you get shot. This is different from the shock line mode, because when hitting the line, it doesn't need oxygen. So when the gun hits the line, it doesn't vent air. Then the test mode requires oxygen. It will have air out when it is shot. If you don't vent your breath, first check the oxygen cylinder. Or is the nitrogen cylinder open? Then the second point. Make sure both the oxygen and nitrogen cylinders are open. After the gas comes in, it still doesn't come out. Then we need to stop the experiment. Open the gun cover to check. Is the sample broken? Or it's not pasted properly? Or did the gasket inside the gun cover fall off? After our experiment is over, a prompt box will pop up. Click Close. Then click on the home page. There is a network and remote on this side of the home page. There is a lock screen function here. It's the interface that locks the software. Then we tick. Just choose a time when we need to lock the screen. Let's say we choose 3 minutes. We don't do anything. It will lock in 3 minutes. The software requires a password.